In this video, we are continuing with the criterion D practice problem. If you have not watched the first part of this video, criterion D practice using vertex form, I strongly recommend that you watch that first. In the last video, we drew a parabola showing the path of the arrow to hit the green target. We used the vertex form to find the quadratic equation representing the path of the arrow. In this video, we are going to target the purple dot. The starting point of the arrow is 20, 0 and the target is at 3, 0. We see that both points lie on the x-axis, or in other words, we have the two x-intercepts. Since I have the x-intercepts, I'm going to use the factored form of the quadratic equation. Y equals a times x minus p times x minus q, where p and q are the x-intercepts. In our case, the x-intercepts are 3 and 20. So y equals a times x minus 3 times x minus 20. To find a, I need another point. I'm going to draw a small section of the parabola starting here and finishing here at 4, 1. As I mentioned in the previous video, your curve, your graph can be different from mine. That is okay. There are multiple possible correct solutions. You could also start from here 20, 0 to draw a small section of the parabola and use that as your third point. Now I have the third point 4, 1. I'm going to substitute it in the equation x equal to 4 and y equal to 1. So 1 equals a times 4 minus 3 times 4 minus 20. 1 equals a times 1 times negative 16. Rearranging, I get a equals negative 1 over 16. So my equation is y equals negative 1 over 16 times x minus 3 times x minus 20. Now let's graph this on my GDC. I'm opening a new document, add a graph, enter the equation y equals negative 1 over 16 times x minus 3 times x minus 20. The graph is now drawn and I'm going to add the 2 points, the two x-intercepts that I used to derive this equation. So I go to menu, geometry, points and lines, point by coordinates to enter my first coordinate 3, 0. I enter 3, press enter, enter 0, press enter. Now the point 3, 0 has been created. Have to create the next point 20, 0. You can see my mouse pointer. It is still the pencil cursor. It is ready to plot the next point. So I don't have to go to menu, geometry, repeat the process, because the point by coordinate tool is now already active. To plot the second point, all I need to do is to just open bracket. So when I press open bracket symbol, the tool gets activated. I enter 20, press enter, 0, enter. Now you can see both these points lie exactly on the graph, which is not a surprise because we used these points to create this graph. Now we have to use the third point 4, 1 to check if the graph functions correctly. To plot the third point, I'm going to press open bracket, enter 4, enter 1, enter. Now the point has been plotted and I'm pleased to see that it is exactly on the graph. So I'm happy with this equation. There is no need for any corrections or adjustments. So my graph will look like this. Remember, we have to define the domain. So the parabola starts at the arrow and finishes at the target. The domain is the x interval, so it is between 3 and 20. I include the domain 3 less than or equal to x less than or equal to 20. Done. Now my parabola looks like this, and I'm happy with the solution. While doing your assessment, irrespective of whether you choose the vertex form or the factored form, once you have finalized the equation and domain, you have to sketch the graph on the assessment paper. Even if your graph does not look great, even if it's a little bit sloppy, no problem. There should be a hand-drawn sketch on the paper. The correctness of the equation and the domain is what matters. The sketch does not matter much. You still need to give your best effort to draw the graph, but don't worry about it if the curve does not look perfect. For this graph, I found the vertex using the maximum function on my GDC, which is 11.5, 4.52. Let me mark this point here and draw the curve. Now we are done. Finally, let's have a quick review of the criterion D skills. Criterion D has 5 strands, D1 till D5. D1 is identifying relevant information. What information will you need to solve this problem? For this arrow example, we need information like the x-intercepts, the vertex, etc. It is okay to use math vocabulary, but if you are aiming for higher grades, you have to list the required information in the context of the problem. For example, the starting point of the arrow, the location of the target, the maximum height, etc. D2 and D3 are selecting and applying math strategies to solve this problem. Sometimes you will be asked to explicitly list the strategies. For example, you could say something like, I'm going to use the coordinates of the start and end points of the arrow, draw a small section of the parabola, and use the coordinates to approximate the vertex, or I will use the vertex form of the equation, I'll use GDC to verify my solution, etc. So listing these strategies would be D2, and D3 will be actually applying the strategy to solve the problem and to come up with the correct solution by choosing the correct formula, choosing the correct points, substituting and solving correctly. All of that is D3. So D2 is choosing the correct strategies and D3 is applying the strategies to arrive a correct solution. D4 is the accuracy of your solution. How accurate is your proposed solution? There are 2 parts to it. First, you could talk about what could have affected the accuracy of your solution. For example, are there any approximations or are there any rounding off? For example, in the vertex form, if you use the decimal version for a value, your solution will be less accurate. If you use the fraction version, then the solution will be more accurate. We can also talk about the accuracy of hand-drawn graphs, how it is going to be less accurate. You can talk about estimating the vertex by just looking at the shape of the graph, those kind of stuff. The second half could be discussing any assumptions that you made. For example, you assume that the scale of the graph given to you accurately reflects the real life situation. You are also assuming that the distance between the target and the arrow is accurately reflected on the diagram that was given to you. If your criterion D assessment involves data collection or analyzing of data, then you could also question about the reliability of the data. Where was this data taken from, who collected this data, and so on. But for this example, that is not applicable. And D5 is justifying how reasonable your solution is. This can also be approached in 2 different ways. One is that you could talk about your solution in comparison with other solutions. So if you have access to somebody else's solution, or if there is a universally accepted solution, then you can compare your solution with that solution, talking about whether your solution is too high or too low, and come up with reasons what could have caused this difference. The second part is that if the scenario is to happen in real life, what real life factors could affect your solution? For example, there could be adverse weather conditions. So it is so windy that the arrow did not travel as expected, or the archer was not skillful, or the equipment, the launcher is defective, or the archer got distracted when he released the arrow. Like these kind of stuff. If somebody is going to actually follow your solution and going to use it in the real world. What other real life factors could affect your solution? So that's it. Criterion D is a combination of both math part and also the real life application part. I hope you find this video helpful. Thanks for watching.